Hello friends, welcome to my YouTube channel of Debneel's Mathematics Desk. So I think that today we are probably back with the hardest part of circles for class 9. Okay, it's part 3 is also there, but I don't think the concepts in part 3 can be harder than this. So basically the things we learned in previous video, that if in a circle we draw a chord and we draw perpendicular on the chord from the center of the circle, then the distance of that from the center to the point on the chord of the perpendicular, that is the distance of the chord from the center of the circle. It's as simple as this, a circle like this, which I don't know how to draw properly. And if you draw the center here, I have a chord here, suppose AB. What I can do, suppose this is the center O, the circle. I draw perpendicular here and sub AM. Then OM is the distance of the chord from the center of the circle. And then we know that from the center of a circle to a point on the circumference of the circle, that's the radius, right? So here either OB, OA, anything can be the radius. And also we learned that as OM is a perpendicular to AB, so OM divides AB into two equal parts. That is AM equal to OB. So if you have AM, if you have the radius, then you can find the distance of the chord from the center of the circle. How? This is the Pythagoras theorem. Suppose this is right angle here. Hypotenuse square equal to base square plus height square. So you can find it like that. That's what we learned in the previous video. But I told you at the end of the previous video that we are going to go through some serious proving based questions in today's video. So let's learn a few things before we go into the sums. I'm loving this. I hope you all remember it. I'm not going into circles now. I'm coming to two triangles. Suppose I have two right angle triangles. Okay. Where they are right angle here. Okay. Suppose this is one case. Now, suppose I have some names here. A, B, C and suppose D. So what triangles do we have here? We have triangle ABD, triangle ABC. Now, how can we prove that these two triangles are equal? This is the new concept we are going to learn today, that is congruency of triangles. Where what you have to do? You have to see both the triangles and take any three same measurements. Like suppose in both the triangles, if you have two angles common and one side is common between them, means same, then that is one rule, that is angle side. By this rule you can prove that triangle ADB equal to triangle ABC. Just like this case, see here ADB is equal to ABC. So obviously these two are right angles, that is each are 90 degree. So angle ABD equal to angle ABC. Yeah, that's 90 degree. Okay. Then what else can I do? Yeah, another thing. Here AB is common. AB equal to AB common. Now suppose I have a condition that B is the midpoint of DC. Okay. Suppose it's like that. If you are given in a question, B is midpoint of DC. Then what do we have here? DB equal to BC, right? It divides DC into two equal parts. So DB equal to BC equal. Then, so what did we do here? So it can be written in this way. There are some few rules which are side angle side, where at first from the two triangles you prove that two means any of the two sides of them are equal. Then in the next statement you prove that any of the two angles are equal, and again in the next statement you prove any of the two sides are equal. That is its side angle side rule. Okay, so here I can't have means more angles. So this is actually another rule is the angle side. Means in the first angle means the first two cases, for each of the case you prove two of the angles of these triangles are equal. And the last case you prove two of the sides are equal. An angle side rule, by that you can prove that these two triangles are equal. Okay. So it can be this as another rule, side angle rule, where you can just do what? First you prove two sides are equal, again you prove another two sides are equal, and again angle means you prove two angles are equal. So three statements are equal, side angle. So that is a side angle rule, using which you can uh, find that proof that these two triangles are equal. This rule actually is applied here. How? See, first what I did, I just no this rule applied angle side or side. Yes. So first see, here AB is common, AB equal to AB common. So what did we do here? We proved that two sides are equal. So one side done. Again, as B is the midpoint of BC and DB equal to BC equal, we proved another two sides are equal. Again, what do we have? Angle ABD equal to angle ABC, because both of them are 90 degree. 90 degree. Therefore, triangle ABD, congruent sign is like this. Triangle ABC. It actually means these two triangles are equal. And one more thing, if you have proved that any triangle is equal to the other triangle, so see here, we have here AB is equal to AB, DB equal to DC, and these two angles are equal. But we are not means mentioning that AD equal to AC. That's the rule. If you prove that two triangles are congruent, then if you have any two sides or any angles remaining, so then those angles or sides are also equal. So as we have proved that these two triangles are congruent, by which rule? Side, again side, then angle. So SSA rule. To prove they are congruent, so we can just tell that AD equal to AC. And I am telling you, this problem will come in large fraction in the questions today. Okay. So why? This is known as CTCT. What does that mean? Corresponding sides of congruent triangles are equal. Okay. That's right. Because see, we have proved these two triangles are equal by just proving that two sides are equal. Okay. These sides are equal and these sides are equal. And these angles are equal. Side angle method, we prove that the triangle is equal. Only you need three conditions to prove that the triangles are equal. Okay. As the triangles are equal, therefore the sides we didn't prove, they are also equal. So AD equal to AC. That's easy, right? That's all. So this is side angle rule. What else can we have? I can explain it through an example. So we will see the questions actually. You can understand what is the rule, right? Means you can use any rule to prove that the triangles are congruent. And if you prove that the triangles are congruent, then if you have any sides of the triangles remaining which you didn't prove they are equal, then they are also equal because the triangles are congruent. If you have two triangles equal, then any two sides you didn't prove for, they are also equal. That makes sense. So just prove that the triangles are equal by this method. I will prefer using angle side rule and side angle rule actually. Side angle side, actually that's nothing actually. Side angle side, but it's a trick. First you mention AB equal to AB common. Then you mention angle ABD equal to angle ABC 90 degree. So side angle, then mention DB equal to BC equal. Side angle side is AS rule. So they are see SAS, SSA. It depends upon how you write the statements, right? Side angle side or side angle up to you. And if you have any triangle, you can see that two angles are common. Write them first, the two cases. Then you see two sides are common. Write that in the next statement. So angle, angle, side. Another rule. It depends upon the figure and your mentality which rule you want to use. The only condition is you have to prove that the triangles are equal. To prove that, you have to prove at least three statements. Yeah, you can't do this. Okay, don't do that. S, it's not good actually. It's not means meaningless. You can't do that unless the question maker is a mad person and he has mentioned the lengths of the line segments. uh, that is not possible. If it's mentioned in the triangles there are line segments lengths and you can see all the sides are equal, then you can do S, or all angles are equal and A. Okay, you can do that. So this is about congruency of triangles. Okay, so now let's jump into the questions. And always remember the previous formulas, that we are going to just build a chord, draw a perpendicular, use Pythagoras theorem. That's going to be much important in solving all the questions. And let's begin. Question 1. What do I have here? The figure shows the figure. Which figure? We'll see soon. Two concentric circles. Alright. We'll did this kind of stuff in previous video. It's going to be interesting. I'm telling you. Many typical sums are there. And I'm telling part 3 is not that hard. You never know. So surprise may be waiting. And what is this? AD is a chord of a larger circle. Okay, we have some chord AD. We'll see what it looks like. I can understand what can be the question without looking into the figure. So prove AB equal to CD. So this is the figure. So as it's proving, writing statements is going to be easy. This is a circle, first one, and suppose a smaller circle, because concentric circles they are trying to say. Okay. This is the center O. This center is the center of both the circles. Concentric means it has the same center. Okay. And this is the chord which is going to help us to solve this question. It is AD and this is BC. This is all we are given. Now then AD is a chord and O is the center. So I can draw a perpendicular here on OAD and name it M. So OM perpendicular to AD. That means AM equal to MD. Because see, if you draw the perpendicular, it will divide, means AD in both equal parts. Okay. What do you have to prove? Yeah, okay, I just means got lost. Now, if you clearly observe, BC is also chord. They are not mentioning in the question, but see, if you have concentric circles and you have a chord for the larger circle, the smaller circle also has some points BC, which is here. So OM is also perpendicular to BC. That means BM equal to BC we can write. MC rather. Huh. So let AM equal to MD be equation 1 and BM equal to MC be equation 2. Now let's see. 45 to 1 minus 2. So equation 1 minus equation 2. So for AM minus BM equal to MD minus MC. And now this, if you observe, if you remove from AM BM, what do you have? AB. That's quite easy to just look at it and understand. From AM you remove BM, so you have AB. So AM minus AM is equal to AB. Similarly, from MD, if you remove MC, you have CD. From MD you are removing this part, so you have this part remaining, which is CD. My hand wants to stop. Why? Because I found the correct answer. As simple as that. So guys, I told you it's proving, so we will not take up a lot of space. If we have just understand what is given to us, we can just cross these questions. So nothing, we are given. Wait guys, 1 second. Alright, some noise was coming, that's fine. So this is easy, right? You have a chord AD and the figure means quite easy to understand. First forget about BC. You have a chord AD, you have a center O. Draw perpendicular OM on AD. Then AM equal to MD as the perpendicular divides AD into two equal parts. Finished. Now, if you carefully observe, BC is also another chord. So you are drawing OM on AD, then you are also drawing OM on BC. So OM is perpendicular to BC. That means OM is dividing BC into two equal parts, BM and BC. So AM equal to MD and BM equal to MC. These are my two equations. Then AM minus BM equal to MD minus MC. Huh? Now AM, from that you remove BM. You have from this part, you just remove this part. Then you have this AB remaining. Similarly from MD, from this part, you remove MC. Then you have this part CD remaining. That's it. AM minus BM is AB. MD minus MC is CD. We have to find AB equal to CD. Huh? Take care question. Easy. So this kind of question we solved in the previous video, I think, where we were given concentric circles and we were given a chord's length. I think something of that kind was there. I don't remember exactly. But that's the concept. If you have watched the previous video, you can just remember the concept of chords, perpendicular on chords, everything. Easy. Let's proceed. We are going to run like a smooth athlete today. But here is a question that might trouble you. Trouble? We know the properties, you will be telling how can we be troubled? Yes. Just see it. A straight line. What is this straight line? A figure is there, don't worry, is drawn cutting to equal circles. Okay. Two circles. That's quite crazy. Not concentric though. This is going to be interesting. Up to this it is quite easy. Let's see what it is. Equal circles and passing through the midpoint M of the line, joining the centers O and Q. What this is? And passing through the midpoint M of the line joining the centers O and O dash. Midpoint is M. So a tricky question. So actually the two circles are there. Their centers are being joined by some line, and that line's midpoint is M. That's quite easy to understand. Joining their centers O and O dash. O dash is another center just. Okay, don't confuse this dashed. Prove that the chords A, B and CD. Which are interrupted by the intercepted, not interrupted, which are intercepted. Wow, this question took me the whole board. Wow, kind of that, and it's paining. So big questions. Okay, guys, let me have some water. Means it's quite huge kind of question. Writing a paragraph, it's like that. I hate writing paragraphs, you know. It means my hand doesn't like it. I like it to read paragraphs, but my hand doesn't like writing them. So wait a second, okay? We will understand what is it's easy, I'm telling you. Okay, now I'm charged up. So the question is actually beginning now because the figure, if you don't know it, is going to be crazy. So nothing, two circles, right? And they're equal. See, equal circles. They are means giving us a hint. Hey, you have equal circles. Don't be foolish. You know what? We are not foolish. Yes, my circle drawing is looking like a foolish man, but I tried my best. We like chapatis, whatever you can tell them. So there are two centers of the circles, O and what else? O dash, right? They are telling that these two are joined by line. Okay, get it here. So these centers are joined by a line, and this one's midpoint is M. Huh, nice. And a straight line is means intercepting the circles. So and passing to the midpoint M of the circle also. That means it's passing to the midpoint and intercepting, joining, not what? It's passing the straight line is not cutting to equal circles. It's cutting the equal circle. Yeah. So like this. It passes to the midpoint. It goes up and suppose meets here. So this is that straight line. That's all actually. So what we can do is here, suppose this big line, straight line is AD. Then this is suppose B, this one, and then this is suppose C. Then AB and CD are chords, right? That's quite making sense. You know what is a chord, a straight line on the circle, on any part of the circle except on the center. Okay. So AB and CD are chords. What can we do here? We can do a lot of things, you know. It's nice to do. a lot of things. So here my center is O. AB is a chord. So suppose here I draw OM as a perpendicular. Okay. And similarly here, O is my center, O dash is my center, CD is the chord. I draw a perpendicular O dash N uh, on this chord CD. Suppose this is one case. Okay. Then what do we have here? Obviously, as OM is perpendicular to AB, therefore uh, BM, which is this, equal to AM, yes, MA, 1 by 2 into AB actually. Yes, means if I take BM, means because of this chord OM, it has been divided into two parts, AM and MB, so it can be half into AB, BM actually. Okay, so half into AB. Okay, wait, guys, I'm just figuring it out. All right, all right. Wait. Don't go for this. Don't just go for this. So did you observe we have two triangles now? O M. Wait, what? Okay, so I can name it OP actually, and this one can be O dash 10. So we have two triangles, OPM and what is this? M O dash 10. We have these two triangles if you just observe. So one thing is for sure, here these two are right angles. This one's this is the perpendicular here, so this will be on the right angle. Okay, now what if we try to prove that these two triangles are congruent? How? Let's see. So here what will we do? Let's just see. So one thing is that angle OPM equal to angle NC or what? This is ONC. OPM and okay, O dash NM. Yeah. So angle, okay, I just didn't finish writing here. OM perpendicular to AB and O dash 10 perpendicular to CD. Yeah. This is clear. Then for these two triangles, these two are right angles, so right angles will be equal. So angle OPB equal to angle, what is this? I just can't figure it out. O dash NM. 90 degree. 90 degree. Then what else do we have here? Let me just see. We don't have much. Okay, another thing. Here, if you just observe these two angles, just carefully observe them. They are vertically opposite angles. So this is a case. Okay, if you have two triangles like this, and these two angles, they're vertically opposite angles. Okay, so angle OMP equal to angle O dash MN. O dash MN. So these are vertically opposite angles. All right. So what else do we have here? Let me just see. So we have just proved that two angles are equal. So we have that angle side rule. I was saying that if we can do something to prove that. So it's a straight line cutting to equal circles. All right. So O dash C, I can't do that. What else can I do? Prove that midpoint of aim of the line joining the centers O and C. It's quite tough. I am getting confused actually. To prove that they're congruent, you have to be smart. Let's see that. So OM is and centers O and O, midpoint of the, okay. So OP is we just see guys, wait a second. So we have to just prove that these two chords are equal. See, if we can just do it, it's going to be easy. How can we prove that another side is equal? Okay, so angle OPM is equal to angle, so those are right angles. So is PB, not PB, PB equal to MN? Oh. Oh wait, just see this. I just means didn't notice it. So M is the midpoint of O and O dash, right? So that means OM is equal to O dash. M O dash, sorry. O dash 10. Just see that. I means was not observing that. So we have proved two angles are equal. One, these two right angles, and then we prove that this vertically opposite angles OMP and what are you? N and not N. O dashed MN. The vertically opposite angles as you can see. Okay, so that they are equal. And as M is the midpoint of this joining of centers, so OM equal to O dash 10. Okay, equal. So what we have here? By angle side rule, we first prove two sets of angles are equal and then prove one set of lines are equal. Triangle, what is this beautiful triangle here? OPM. Oh, this right angle is OPM. I wrote it OP. What was that? B. Here, call a triangle O dash M here. Triangle OPM is, this is the sign of congruency. Is this triangle O dash MN? Now, what do we learn? If two triangles are congruent, then their remaining sides which we didn't prove they are equal, they are also equal. So here OP is equal to O dash 10. Therefore OP equal to O dash N. CPCT, what is that? Corresponding parts of a congruent triangle. Okay. So that's it. Means see, if you prove that any two triangles are congruent, and if in the three statements you haven't proved any two sets of lines are equal, but you have proved by another sets of information that they are equal, then those remaining sets of lines are also equal. So here OP equal to O dash 10. Now these two circles are equal. We have that information. Okay. So and that means what? The distance of the chord AB from the center O is equal to distance of the chord CD from center O dash rather. What is that? If you know that in two circles, two equal circles, the distance of your chords from the center is same, then those two chords are also equal. We learned that, just remember it. We just learned in the previous video that if you have two circles, at two centers, you have two chords. The distance of those two chords from the respective centers, if they are equal, then those two chords itself are equal. So we can write therefore the chords are AB and CD, AB equal to CD. We did it. Easy, right? Not easy, but it took a few statements. So I can just write in triangle OPM and O dash M and triangle O dash M. So these are the statements, right? We proved two angles 90-degree. We proved vertically opposite angles. Proved that these two sides OM and O dash M are equal because midpoint is bisecting them. Then what else? Angle, side rule. You prove that the triangles are congruent. Because the remaining sides of those two triangles are also equal. So that is OP equal to O dash 10. And if you know that the distance from the center of two chords of two circles are equal, then those two chords itself they are equal. Okay, just remember that. If you remember that, you can just smash this question out of the way. Just read it. So again, drawing the perpendicular helped us quite nicely, and congruency, angle, side. You have learned it by now. That how can you do that? Any three sets of information you have to give, which can be angle, side, angle, side, anything you like. But don't do that. What do we say? Side, angle. Don't do unless the question maker itself has mentioned in the question to you. Okay, the figure, and that's how you just complete it. Let's see the next one. So see, you can get confused, so I'm also getting confused, right? That's why I told that this video is going to be a bit hard. Now comes a very insane question. This is much more harder than the previous one. So wait guys, 1 second. Okay, we are good. Let's see. So here I have M and N are the midpoints of two equal chords AB and CD of a circle with center O. Nice question. AB and CD. It's a good question, but this is actually the logic is easier than the previous one. You have to apply Pythagoras theorem here. We will just see how it's done. Of a circle with the center O. So means personal training. I was not good at circles, but I was in like class 9. Failed miserably the beginning stages, but somehow my friends, I think actually some of them helped me understand that, tease me actually that I didn't understand it, but then I just figured it out that hey, come on, it's not that hard. So if you have problems in this chapter, just do it like that. And surprisingly, we don't have much information other than this single line, but we have a figure. Proof. Give us a proof. Means it's nice that they are giving us the figures, otherwise it means the figures they are means desiring that can't be means made out from our mind. It can happen. So For these questions, please give us a figure. I will urge them to do that. Just like here, proof. What is the proof here? Angle BMN equal to angle DNN. Another one I have to prove. Angle AMN equal to angle CNN. Quite easy. Now the figure. Means my task is to draw good circles, I hate it when they don't come out nicely. Somehow oval shaped figure came out. So we have two chords here. A, B and C, they are like this. Whoa. They are equal. So A, B, here A, B, C, D, and suppose M is the midpoint of AB and L is the midpoint of CD. Okay, and they have a center O. Okay, slightly over. That's actually nice. Okay, you have given us a center. You have given us two chords. So if I actually join OM here and ON, so if you have, suppose you don't have this point M and you draw a perpendicular O and then you name it M, then OM perpendicular to AB means OM dividing AB into two equal parts. That also means that M is dividing AB into two equal parts. That's the making sense, right? So M is the midpoint of AB. We know midpoint is what? A point which separates a line to equal parts. So let M be that point. That means OM is actually the perpendicular to AB. Similarly, ON is perpendicular to CD. So OM perpendicular to AB, ON perpendicular to CD. And then you know what? Join M and N. I'm now going to show you how to do this question. You join M and N, okay? Then you join OB and OD. Now, one thing you see, OB and OD are both the radius of the circle, right? Because from the center to any point of circumference, that's radius. Therefore, OB equal to OD, radius, right? Remember this? Now, here comes a very nice statement. See this. So, here BM equal to half of AB so BM is half of AB actually. Now AB is half is actually CD is half because see AB and CD are equal. So if I divide AB by 2, suppose it is 15, then CD is also 15. So CD by 2 it will also be 15, right? As its chords are equal, their halves will also be equal. So BM is actually a half of AB, right? Which is equal to half of CD. Okay. And you can write that as ND. Huh? So BM is equal to ND actually we can write. Oh, not 2 damn. 1. The halves of the chords will be equal, right? Because the chords are itself equal. Okay. And these halves are happening because of the perpendiculars. We know that. Now, here one more thing we are going to see. So we have two triangles if you observe, and as OM perpendicular to what is this? AB. So this angle, this one. So OMB is a right angle triangle. Similarly here, where my head is like swinging. How is not coming out nicely? What is wrong with the figure? Nothing. So here also this angle ON, this is also right angle. That means, to summarize, OMB and OND are right angle triangles. So for OMB, triangle OMB, you know the formula hypotenuse square, which is OB square equal to base square, height square OM square plus base square MB square. Okay. Now if I take OM square to one side, or OM square equal to, so OB square minus MB square. Okay. And so we learned that OB is equal to OD because they are the radius of same circle. So OB square can also be written as OD square. And we just saw that BM or MB is equal to ND. So MB square can also be written as ND square. Now, so if I see for triangle OND, here you will see that hypotenuse square, which is OD square, equal to, so height square ON square plus base square ND square. Okay. Therefore, if I take ON square to one side, or ON square equal to OB square, OD square minus ND square. Wait, what? See, this is equation 1. This is equation 2. Hello. ON square and ON squares values are same. Because OB is OD, radius of same circle. And we just proved that BM is equal to ND. Oh my god, that's a good proof. Then OM square and ON square's values are same. So we can write, or OM square equal to ON square. If you just do the root, or OM equal to ON. Now you'll be telling, what is the purpose of wasting so much time to prove that OM equal to ON? Well, you'll soon find out. So we have a property. If OM is equal to ON, then the respective angles are also equal. You didn't understand that? OM is equal to ON. Then their angles OMN and ONM, they are also equal. See, OM, so M is here, so OMN. And ON is here, so ONM. So these are equal, okay? Therefore, angle OMN, angle ON, means if you have two sides, then the respective angles are also, if two sides are equal, the respective angles are also equal. Okay. So then we have this. Now another thing, angle OMB equal to angle OND. Let this be equation 2. No, 3 actually. This is 2, right? And another equation, angle OMB, this is right angle. Angle OMB equal to angle OND. Both are right angles, 90 degree. Suppose this is 4. Okay. Now, from 4, if I just subtract 3, so 4 minus 3 means what? That means angle OMB minus angle OMN equal to angle OND minus angle ONM. Okay. Is this true? Is this true? This is the angle OMB. From there you just subtract this angle OMN. See this. This is the angle. From there subtract this angle. Then you have this part remaining. That is BMN. Just see it. This is suppose the angle OMB. Okay. And then you have an angle like this. Suppose this is OMB. This is suppose OMN. This is OMB. This is OMN. So from OMB, if you remove OMN, you have BMN remaining, right? Yes. So angle OMB minus OMN is angle BMN. Again, from angle OND, if you remove angle ONM, then you have what? DNM remaining. Again, I am showing you. This time it's in the opposite direction. Suppose like this. This is suppose the angle is OND. So OND, and you have suppose angle like this. This is ONM. Okay. Then from angle OND, you remove angle ONM. What do you have? Angle DNM remaining? Yes. So OND minus ONM is angle DNM equal to angle DNM. So OMB minus OMN is BMN and OND minus OMN is DNM. Therefore, angle BMN equal to angle DNM. Wow, nice proof. Was pleased with that one. What is this? This is the first part. I'm not joking. This is the right proof actually. We have proved it. Similarly, let's do it for the second part. This is the first proof. Now, if you just carefully, I'm not writing here, okay. Why do I write? It's taking so much space. Okay. So, angle AMN is not angle AMN. Brain stop working or what? Okay. It's angle AMO, OMA. It's a right angle. So, see, if OMB is the right angle, then OMA is also a right angle because of this perpendicular OM. Similarly, here, as ON is the perpendicular on your CD, so that means OND and ONC, they are right angles. That means OMA and ONC are right angles. So I can write angle OMA equal to angle ONC 90 degree. Huh? Let this be equation 5. Then I had a relation that angle OMN equal to angle ONM. So if I do 3 plus 5, that means, or angle OMA plus angle OMN equal to angle ONC plus angle ONM. Now see this. We had the angle OMA. I had OMN. What does the actual angle become? AMN means it's like this. You have this angle. Suppose it is your OMA. Oh, what is O here? I am confused. And you end up adding OM. Suppose here another segment N. If you have these two angles, what is this? AMN. So OMA plus OAN is equal to AMN. Similarly, to angle ONC, if you add ONM, it will become what? CNM. I am again doing it. See. So it's angle ONC then. Writing in this way. It's ONC. Okay. So to this you add ONM. So suppose ON and here I add another segment M. And this total angle is what? CNM or MNC or CNM I am writing equal to angle CNM. OMC plus ONM is CNM. I can see one thing. This is the proof. That's the answer. We did it again. See, it's easy, right? Just we solve that how you see. First what we did, we had the initial diagram. We drew OM and ON as perpendiculars on AB and CD. That meant what? AM equal to MB and CN equal to CD, ND. And as these two chords are equal, then their halves will also be equal. That is, MB will also be equal to ND. Okay? Or BM will be equal to ND. That was our first equation. Then we had two right angle triangles here. Why? See, OMB is a right angle because OM perpendicular to AB, and OND is a right angle because ON perpendicular to CD. Then for the right angle triangles OMB, I just see OB hypotenuse square equal to OM height square plus base MB square. Then if I take OM square to one side, it will be OB square minus MB square. Now OB equal to OD. Why? They are the radius of one circle only. A circle can have only one radius. So OB and OD should be same. So OB square is actually OD square, and we proved that BM is equal to ND. So MB square equal to ND square. So AM square equal to OD square minus ND square. I kept it as equation 1. Then I went into right angle triangle OND. And then I saw hypotenuse OD square equal to base ND square plus height ON square. Okay. Then taking ON square to one side, it is equal to OD square minus ND square. Then I see that OM square's value is equal to ON square's value. That is OM square equal to ON square. And if I take root, OM equal to ON. And that is another, what we learned the property. If two lines are equal, then the respective angles, okay, on the segments. If two lines are equal, then the respective angles on the segments, they are also equal. Okay, it is OMN equal to ONM. We learned that. I kept it as equation 3. Then I see that these two are right angles, angle OMB and OND. It is angle OMB equal to angle OND equal to 90 degree. I kept it as equation 4. Then from equation 4 I subtract equation 3. Then angle OMB minus angle OMN, which you clearly see OMB minus OMN is BMN equal to angle OND minus ONM. And if you see OND minus ONM, it will have DNM remaining. Okay. So angle BMN equal to angle DNM, and that is our first proof. Finished. Now you see, as OM is perpendicular to AB, therefore OMB and OMA are right angles, so OM is also right angle. And similarly, ON perpendicular to DC, therefore ONC and OND are right angles, so ONC is also right angle. So I can just write that angle OMA equal to angle ONC equal to 90 degree. I can write it. Let it be equation 5. Then to this equation 5, if I add this equation 3, okay, and what happens? Angle OMA plus angle OMN. OMA plus OMN. You are increasing the angle, it will become AMN. I have showed it here. For where did it go? Oh, yes, OMA, and you just do OMN again. So it is AMN together. Angle AMN. And similarly, ONC plus angle ONM. Then what together it becomes CNM. Huh? So angle AM equal to angle CNM. That's the second proof. So here we did many things. First we proved that the halves of these chords are equal. Then by Pythagoras theorem, we proved that OM equal to ON, and that means the angles of those two lines on the segments are also equal. Then we see that OMB equal to angle OND, right angles. We take that as an equation from 4, we do minus 3. We have the first proof. Similarly, we have angle OAM equal to angle ONC, 90 degree. Keep it as equation 5. To equation 5, add this equation 3. We have the second proof, angle AMN equal to angle CNM. And that's how we end this question quite easily. I think I missed out something. It's not CMN, it's CNM. So guys, see, any question can be this long, but to logically see it, you are doing a lot of less things. It's nothing. You have the chords, you draw perpendicular, therefore two right angles on each of the chords. Both the chords are equal, so the halves will also be equal. Then by Pythagoras theorem, just find out that OM equal to ON. Then you see the two right angles, therefore OMB, OND and ONM, ONC, they are equal. Take them as two equations. In the first case, do equation 4 minus 3. In the second case, do equation 3 plus 5. You will have your required proofs. As easy as that. Now let's move on to the next one. And if you have any doubts on this question, you can do zoom. You can pause and see what is the proof to understand it completely, because it can be that you miss out on something. But I hope there is nothing that hard to miss out on. Let's see. What else do we have? Oh, what's this? Low. Oh, this is a very good question. So a last question should be a hard one, right? Let's see if we can make it hard. The length of the common chord. Huh? I'm just thinking that this might be the easiest question, Let's see. The length of the common chord of two intersecting circles is 30 centimeter. Wow. If you are getting a common chord, there means decreasing our difficulty by 50%, I'm thinking. You will see why. A chord means only a one chord. It's quite easy. And besides that, giving its length. Wow, finished. Sum is finished actually. Not actually, we'll solve it. Did I write the spelling of intersecting correctly? Yes, I did. I can't mistake that. Of two intersecting circles. Now, this is interesting. Circles are intersecting, so we will see. We are not given the figure. This is the difficulty of the question. So, the circles are intersecting and they have a common chord. So, you remember Venn diagram where you can just means intersect two circles and the common part of those two circles, that is the intersection, means the common things in both of those circles. We learned that. So if we draw a chord on that common part, that can be the chord for each of the circles. We will see how we can do that after this question. Circles is 30 centimeter. Much more is there in this question. If the diameters of these two circles are 50 centimeter and 34 centimeter, yes, you know, but we know the formula of diameter, which is radius into 2. So radius is diameter by 2. Anyway, trying to increase the difficulty by changing it into diameter, thinking we are fools, but we will make them the fool. If the diameters of these two circles are 50 centimeter and 34 centimeter, calculate the distance between the two centers. I didn't see that coming. Wait, what? This is a bit different, right? And besides, we are not given the figure. So overall, it's turning out to be difficult. We will have to go wisely. In fact, I am just forgetting what can be the figure. I just tried to solve this sum on a paper and I got the figure I know. So let me just think actually. Two circles if I intersect. Okay, okay. We will do step by step. The distance between the two centers. We have this question here and we need to draw a circle actually. Not a circle, two circles. The drawing of these two circles can decide if you are going on the right track or not. So like Venn diagram, we will draw here two circles that are intersecting each other. See this. One circle doesn't look like a circle. Try to adjust. I'm a not good drawing man. It went good, right? It's better than the previous. Come on. Another circle. It starts around here, intersects it. I think I can make you understand. So these are the two circles then. They are intersecting each other. Then the intersecting part is this part, this common part. So if I draw a chord here, then see, this chord is actually the chord of both the circles, right? This one and this one, another chord. Now, so the length of the common chord is 30 centimeter, which I will not write now. So the diameters, obviously the circles will have some center. Suppose this is the center. Now, suppose the center is O. This chord's name is AB. This center is Q. Then for this circle, OA and OB can be the radius, right? Because from the center to any point of circumference is the same, means radius. But we are given diameter. So Radius are what? Diameter by 2. First diameter by 250 by 225 centimeter, and second one 34 by 2 17 centimeter. Yeah. That means so radius is your what? The from the center to any point of circumference. So if I join OA and OQ, then OA and AQ, they can be the radius of the two circles. Suppose this is the radius 25 centimeter of the first circle, and this is the radius 17 centimeter of the second circle. Then from the center, if I draw a perpendicular on AB, suppose OM, then OM perpendicular to AB. Similarly, if I draw perpendicular MQ on AB, then AB is perpendicular to MQ. This M in the middle of this horrible stuff got vanished. We have got the figure actually. So what does it look like? First, two circles intersecting. The chord placed in the intersecting part can be a chord common to the circles. Then radius is from the center to any point on the circumference, that is the radius. If I take O as center of one circle and Q as the center of another circle, then OA and AQ can be the two radius of both the circles, which are 25 and 17 respectively. Then join OA and AQ. Then draw perpendicular OM on AB and MQ on AB. Okay. Then I can write OM perpendicular to AB and AQ perpendicular to AB. On AQ, I am a mad person. MQ perpendicular to AB. That means, so I am now writing the values here. So considering any of the perpendiculars OM or MQ, they are dividing AB into two equal parts. That means AM equal to MB, and we have that the length of the common chord is 30 centimeter. AB equal to 30 centimeter. So that means AM equal to MB equal to what? 30 by 2, 15 centimeter. Why it is getting divided AM equal to MB? Because OM and MQ are dividing AB into two equal parts because they are perpendiculars on AB, right? The chord. Then you have everything. Finish the job. What do you have? You have this AM, which is 15, which I can't write in the small place, therefore. Now another thing, as AB is perpendicular to OM, that means angle this one, this is the right angle. Similarly, if I look into this side, MQ perpendicular to AB, then this one is also a right angle. That means OMA and AMQ are right angles, right? Right angle triangles. Therefore, for triangle OMA, for hypotenuse squares, OA square equal to AM square, height square, plus base OM square. Okay. Now if I do, or OM square called OM square will be what? OA square minus AM square. So OA, the radius of first circle, I can take 25 centimeter. It's the radius. 25 square minus AM is what? Half of AB, which is 30 by 2, 15 centimeter. 15 centimeter square. If you calculate, it will be 625 minus 225, 400 centimeter square. And then OM is just root of that, or OM root 400, which is 20 centimeter. We got OM. Now AMQ is also a right angle triangle, so I am now going for AMQ. If you do good sums, you score good marks. So we should do good sums, right? We all love marks. AMQ is a right angle triangle. So hypotenuse AQ square, Pythagoras theorem showing its power, equal to height AM square plus base QM square, NQ square rather. So then if I take MQ square to one side, or MQ square equal to AQ square minus AM square. So AQ is what? The radius of the second circle, right? That is 17 centimeter. Minus AM is what again? Half of AB, which is AB's length is 30. The chord half of AB means AM 15 centimeter. And if you calculate this, 289 minus 225, it is 64 centimeters square. That means MQ square is this. Therefore, MQ equal to root 64, which is 8 centimeter. Now you will be telling, why did you find out OM and MQ? We have to find distance between centers. We have to find that is OQ. So I can write therefore OQ equal to OM plus MQ. Right, OM plus MQ is OQ. That's, don't ask me why I'm doing that. And we found out OM as 20 centimeter. Now the logic is clear. And just now, like a hot meal, we found out MQ 8 centimeter. So 20 plus 8, quick maths, 28 centimeter. A very appropriate answer which can guarantee you 4 marks in this question. And you have it. OQ is what? Distance between the centers O and Q. That is the answer. Finished. So I didn't have to do that much in this question, you know. I had to draw the figure. Everything was given to me. I draw the intersecting circles, and the intersecting part in that, if I draw the chord, that's the common chord between the two circles. Okay. I have named that chord AB. The two circles have two centers O and Q. Then OA and AQ are the radius of the two circles. From center to any point on circumference is the radius we know. So I take OA as a radius of first circle, which can be 50 by 2, 25 centimeter. Why 50 by 2? Diameter is 50, radius diameter by 2. And similarly, radius of the another circle AQ can be 34 centimeter by 2, 17 centimeter. Done with that. Now I draw a perpendicular OM on AB, a perpendicular MQ on AB. So these two do what? They divide AB into two equal parts, AM and MB. Now I have that AB is 30 centimeter. Okay. So AM equal to MB equal to 30 by 2, 15 centimeter. Done. Now see, as AB is a chord and OM is perpendicular on that. So these two are right angles, OMA and OMB the right angles. Similarly, MQ is perpendicular on AB. Then AMQ and QMB, they are also right angles. In short, OMA and AMQ are right angle triangles. Coming to right angle triangle OMA, hypotenuse OA square equal to base AM square, height AM square plus base OM square. Taking OM square to one side equal to OA square minus AM square. OA, the radius of first circle, we found out 25 centimeter square, minus AM, which is half of AB, which is 15 centimeter square. 15 centimeter, why? The length of the chord AB is 30 centimeter. So half of AB will be 15 centimeter, 15 centimeter. 25 square minus 15 square is 400 if you calculate. Then OM equal to root of 400, which is 20 centimeter. Then coming to right angle triangle AMQ. So in that one, hypotenuse AQ square equal to height AM square plus base MQ square. If I take MQ square to one side, it will be equal to AQ square minus AM square. AQ is what? Radius of second circle, which is 34 by 2, 17 centimeters square, minus AM is what? Half of AB, the chord, is 30 by 2, 15 centimeters, 17 centimeters square minus 15 centimeters square. You calculate, it will get 64 centimeters square. And MQ square is this, so MQ will be root of 64 centimeters square. 64 root is 8, 7 centimeters squares, root is centimeter. Okay. Now I have found OM and MQ. We have to find distance between centers. Distance between the centers are O and Q. The distance between them is OQ. OQ is equal to OM plus MQ, which is OM we found out 20 centimeter plus MQ we found out 8 centimeter. 20 plus 8, 28 centimeter. That's all. So these two videos actually prove us that you learn congruency, you learn vertically opposite angles, anything. You should learn for the circles chapter the property that on a chord, if you draw perpendicular, the chord gets divided into two equal parts and it makes two equal right angles on the chord, right? By that, you can use Pythagoras theorem to find out the remaining components. That's it from part 2 of circles for class 9. Nothing else we have today. But part 3, other than this chord concept, what else important is there? We are going to learn that. So get ready for that. It's going to be interesting. So till then, if you found a video on circles part 2 for class 9 very informative and helpful, and if the advanced concepts of chord and perpendicular were clear to you, and also if congruency of triangles and its rules, which are angle angle side, side side angle, side angle side, and what else? Yes, these three only, I think. Yes, these three. So if these rules are clear to you, where you just have to prove 3 statements in 2 triangles that they are equal, to prove that those triangles are equal or congruent, and to prove that the remaining parts of those 2 triangles, they are also equal. If that was clear to you, and if all the sums we did today, the most important one, they were quite clear and helpful for you, leave a like and share and subscribe my channel, because see, I am now halfway through my exam. So you can be arguing that why wasn't I uploading videos for 2 to 3 days, because I have my physics paper and shortly after one day I have my English paper as well. So in mid of that, I am trying to provide my time for you all. So I expect some love and support from your side. Show that to me to encourage me to make better videos on these interesting chapters. See you in the next video with a lot of new concepts on part 3 of circles. Probably the last part, I don't know, it can be extended to part 4. You'll see what to do. Till then, take care and goodbye. Thank you. Have a nice day.